Welcome to the start of this series on problem solving. So the first question or problem to answer is, what is a problem? Now the most basic definition is a problem is any given situation that differs from a desired goal. Now problem solving is the process of solving a problem, the bit in the middle. This process may be formal or it may be ad hoc. Depends a lot on the type of problem. Believe it or not, there are problems that are inherently difficult to define. For example, imagine you draw a painting and I tell you, we have a problem. This painting is nowhere near beautiful enough. Please draw me another, but this time make it a beautiful and interesting painting. Now imagine trying to write requirements for a beautiful and interesting painting. The phrase, I know what I don't want, but not what I do want, comes to mind. But instead, there are problems that can be well defined. My radio doesn't work. Fix my radio is a problem. Unlike the painting, we have a clear defined NOK state and a clearly defined desired state. Although fixing the radio may have some complexity behind it. Now, one way to solve the problem is to buy a new radio or send it to a shop for repairing or replacement. Now, in this case, have we fulfilled the requirements? Because sure, we've replaced the radio, not fixed it. And this is something we're going to talk about later with reframing problems. So let's look at some fun facts about problem solving from the animal kingdom. Well, crows can solve puzzles as well as 5-year-olds. Dolphins call each other by unique names. Dogs can learn hundreds of words, although cats are slightly better than dogs at problem solving. Well, that depends if you're a cat or dog owner. Chimps are crazy good at memory puzzles, and octopuses are weird problem solvers, meaning due to the difficulty of studying them, we haven't touched the surface of their capability, pun intended. There is still some controversy if there's a direct correlation between brain size and problem-solving capability. The general view is that it is, but some say it's more related to the size of the problem-solving area in the brain than directly the size of the brain itself. Now going back to humans, for humans the prefrontal cortex near the front of the brain manages much of complex problem solving, along with some other areas, and works even when we are not consciously thinking about our problem. Ever been stuck on a problem to go away and have a coffee or do something else and then come back with the solution? Einstein and others both commented that when they stepped away from their problem and took a break, they came back with a solution. The common theory behind this is the unconscious portion of your brain works on problems using different processes than your conscious brain. To unlock these unconscious functions, you need to disengage your conscious portion on the problem and allow these processes to work. Also, sleep and dreaming is also being linked to helping manage complex problem solving. Now, problem solving is strongly related to how we think. And even as far back as the 1920s, psychologists started to look into problem solving. And they viewed problem solving as depending on the frame of mind of the person. And they called this process restructuring. So let's give an example. Imagine two children are playing tennis. The older one is far more experienced than the younger boy and keeps winning. The less skilled boy gets upset with always losing and wants to stop playing. So now the older boy has a problem, which he has nobody to play with. He's bored. Now the options here for the older boy is offer a reward to the younger boy to keep playing, or let the younger boy start to win, or embarrass the boy to try and get him to keep playing. But now the solution the older boy offered was to change the rules and play a game of how long they could keep the tennis ball in the air, a non-competitive game. Now here the boy reframed or restructured the problem. Instead of the goal to always win, the goal was to keep playing with the boy. His target was not to be bored, to have fun, to play. With the new type of game, the problem is solved. The older boy is not bored, the younger boy is not frustrated. This is an interesting example because we may have thought the goal was to win at tennis. In fact, the object of the game was not the true goal, which was instead to play and have fun. Also, think back to our problem to fix the radio. One way was to solve it by buying a new one. Now, of course, that is only a problem to be solved if you have the money. But we'll come back to this reframing later on. So let's talk a little bit about the type of problems we face. Well, the first problem I call the aha problem. Now, this type of problem you can't rely on past experience or learning. It's something new and not obvious, and it can be difficult up front to predict the likely solution. You may make many attempts at a solution before you finally find one. And when you do, you get aha, it's like this. The other type of problem is the fixer. Now, this is also related to mental states and the way a person looks at a solution and a problem based on their past experience. This is called functional fixedness. Let's demonstrate this with an example problem. Imagine you have a boy in a room. You put him in a room and you give him a spanner. There are two pieces of string hanging from the ceiling, and his task is to find a way to hold both pieces in his hand. But the strings are too short. How can he do it? Well, the solution is to tie the spanner to one of the strings, then swing it. And while he does that, he goes to the other string and then grabs the string as it's swinging. Now, the difficulty with this problem is in a person's mind. They associate a spanner with fixing a nut or a bolt as a tool, not using it as a weight. Their mind is fixed on the use and action of this object. Now, other types of problems are means-ends analysis. Now, that's a complicated way of saying that you have to do sub-goals until you reach your ultimate goal. And we do this in everyday life. For example, if you were to catch a train, first you would have to find out where the train station is, you would have to check the timetable, you would have to get the right connections, you'd have to figure out the best departure and arrival times, all subtasks that lead to your goal. And this is part of our standard life of going through problems. So let's talk about the impact of experts in problem solving. Now, it might seem obvious that an expert in an area will solve a problem faster and better than a novice. But why? Now, studies have shown that experts spend much more time in defining the problem. Now, poorly defined problems are a common source of poor outcomes to problem solving. Also, experts store the information differently and able to access knowledge much faster. But the interesting part, which will follow on to the next section on problem solving, is that these experts spend much more time in defining the problem. It may seem they have a slower start to a novice, maybe at the point of already testing a solution, but this spending their time on defining the problem ultimately leads to them getting a better solution. And this now will follow on to the next part of this section on problem solving, which is how to define problem.